A conservative vector field is path independent. This means if we were to do a line integral on any path over a certain curve, or I should say any curve over from point A to B, we can go like this, we can go like this, like this, any sort of possibilities, but basically if we were to integrate along any of these paths, we get some constant, not always a constant, but we get some value that is always the same. This does not change for conservative vector fields. So a vector field is conservative if it has a potential function. So usually written like this. There are a few ways to see if it's conservative. So the first thing we can do is we could take the curl. The curl is basically a cross product, which is written like this. And when we take this cross product, if it is equal to the zero vector, then this means that the vector field is conservative. In 2D examples, I believe it is called Green's theorem. For 2D, you'll usually see it's Green's theorem, and it's basically, oh well, we have this vector field PQ, and then we say, oh well, if their differentials are equal to each other, if we differentiate P with respect to Y and differentiate Q with respect to X, and these are equal, then we could say that it's a conservative vector field. This is kind of like basically taking the curl, but limited it to 2 dimensions. So if we were to write this curl out for 2 dimensions, say that the z component is equal to 0, that would be so then we decompose this, we get 3 2x2 matrices. So if we have our PQ, I guess we could erase Fy and Fx and put P and Q's. P is the X component, so that would be right here. Oops. P, Q, Q. And then just take the determinants of these, but because we're limiting to only X and Y, we're not going to have Z in any of these, so these are going to be 0, and this would be our P and Q term. But basically when you take the curl, we have our matrix, then you decompose and write it all out. It gets a little annoying, but I'm going to write it out right here. Alright, so this is it written out decomposed. If we get 0 for each term, that means if 0 vector, that means the curl is 0. That means conservative vector field. That's the basics of it. For conservative fields, we just take the curl, equal it to 0. That's basically it. 2D fields. 2D fields. We have P and Q. We do partial by partial x q is equal to partial by partial y p. Oh, that does not look so good. Anyway, thanks for watching.